A very good afternoon to one and all present here. I, Vanchika Singh, on behalf of the organizing team of Ministry of Electronics and Information Technology, welcome you all to the third day of India Stack Knowledge Exchange session. The theme for today's talk is Space Technology Stack, wherein we'll get an insight into the applications of space technologies in the field of satellite communications, navigation, Earth observation, and geospatial data dissemination. We have esteemed speakers from ISRO to walk us through this theme. Mr. Sashikant A. Sharma, Scientist G and Group Director, Space Application Center, ISRO, Ahmedabad, is the moderator for today's session. He has worked in the field of remote sensing, GIS, and digital image processing. He is instrumental in development of geospatial portal, VEDAS, which is visualization of Earth observation data, and archival system, which has visualization and analysis capabilities of geospatial data. Earlier, he was a lead role in development of indigenous GIS software. His current interests are digital image processing, geospatial analytics on web, and AI ML applications of satellite data. He is recipient of many national awards in the field of geoinformatics. Our first speaker for the session, Mr. Nishkam Jain, is currently working as a scientist SF at Navigation Applications Division, Space Application Center, Indian Space Research Organization, Ahmedabad. His team has developed the first NAVIC receiver and SAC ISRO. He is involved in the evaluation and verification of various NAVIC and GNSS applications developed by Indian industries and startups. He'll be delivering his insights today on SatNav, which is satellite navigation. The next speaker is Ms. Vibha Jain, Scientist SF, Space Application Center, ISRO, Ahmedabad. She joined ISRO in 2006 and has worked in the field of satellite communications. Her major contributions include the development of National MSS network for coastal monitoring and real-time aircraft tracking system. She'll be deliberating her thoughts on SATCOM, satellite communications. Pankaj Bodani will be the next speaker. He is Scientist SF, has been working with Space Application Center for the past 12 years. He has over 6 years of experience in design and development of geospatial processing platforms, focusing on high-performance interactive analysis of large data sets. He has designed, developed, and operationalized several AI models for VEDAS in the areas of cryosphere, urban studies, and vegetation monitoring. He'll be sharing his insights today on VEDAS, visualization of Earth observation data and archival system. Mr. Utkarsh will be the next speaker. He is Scientist SF at SAC. His major contribution includes adoption of service-oriented architecture to deliver geospatial services to end users, agencies, and departments, securing cyber infrastructure, dissemination of satellite data through cloud, RSS feeds, and multicasting. He's currently working on thematic data cube and web processing infrastructure to deliver digital services. Mr. Utkarsh will be delivering the talk on ocean and weather services using Mosdak data. The last speaker for the session is Mr. Arul Raj M, Scientist, Engineer, and Group Head, Bhuvan Geoportal and Web Services Group, National Remote Sensing Center, NRSC, Hyderabad. Since the inception of Bhuvan, India Geoportal of ISRO, he is working on geo-visualization and analysis capabilities of geospatial data using open source solutions. His significant contribution also include G-governance application and Bhuvan for various state and central ministries. His current interests are web GIS, 3D GIS, open source geospatial solutions. For today's session, he'll be enlightening us on Bhunidhi and Bhuvan solutions. I now request our moderator to please take over to the session. Thank you.
Thank you, Vanishka. Namaskar and good afternoon to all. I welcome you all on behalf of ISRO to this special session on space technologies tech under ISKE in Digital India Week. Thank you, Mighty, for giving us this opportunity. Indian Space Research Organization, popularly known as ISRO, is the nodal agency to develop and apply space technology in the country. Working along the dreams of Dr. Vikram Sarabhai, we are using these advanced technologies for common man, be it satellite communication, navigation, remote sensing, geospatial services, or anything. Today, we will showcase how these technologies are changing lives of common man in this digital world. We will have 5 presentations of 15 minutes each with question answer session and discussion at the end. We have presentation on Navik, that is and navigation, showing the applications of our Indian navigation system, that is Desi GPS, for a variety of applications. Followed by a presentation on SATCOM technologies, which will showcase applications of satellite-based communication for societal needs. We will have presentations on 3 geoportals of ISRO, namely Bhuvan, Vedas, and MOSDEC, which serves all citizens in the form of web-based geospatial data visualization, dissemination, and analysis. These portals have applications over land, oceans, and atmosphere. It also serves various ministries in India as part of G-governance. I once again welcome you all to this space technology session and request the first speaker, Nishkam Jain, to start the presentations. Thank you.
Thank you very much. I thank for the opportunity to Meti and to Shashikant Sharma sir. I'll be sharing my presentation now. Hope it is visible. So today I'll be speaking on satellite navigation technologies, the concept and innovations done by ISRO. I am Nishkam Jain from Space Application Center, ISRO Ahmedabad. When we talk about navigation, there are basically very few countries in the world who have their own navigation system. GPS, you might all be aware of it. So there are around 4 GNSS providers or global navigation satellite system providers, starting with GPS of US, then Galileo of Europe, GLONASS of Russia, BeiDou of China. And then there are 2 regional navigation, the QZSS of Japan and NAVIC, our own Desi GPS of India, which is a regional navigation satellite system. Along with the navigation system, which are standalone in itself, there are satellite augmentation systems. So there are only 4 countries in the world who have satellite augmentation system, which is primary and augmentation to the GPS system, which are the VAS by US, IGNOS by Europe, then operational one, Gagan by India, and MSAS by Japan. So they are certified by their certifying agencies. Like in India, it is certified by DGCA for flight operations, mainly for civil aviation users. A brief about Gagan. Gagan works on GPS for primary navigation, and the Gagan broadcast correction and integrity messages for enhancing the accuracy of the GPS user. So this is primarily intended for Airport Authority of India civil aviation users, and it is fully operational and it is certified by DGCA for air operations with a very good position accuracy of about 4 meter vertical and 3 meter horizontal. Then after the experience of Gagan, ISRO went on to create its own Indian independent regional navigation system of India, which is called NAVIC, or NAVIC stands for Navigation with Indian Constellation. So it was developed indigenously by ISRO. So we have about 7 satellites in the sky, which make the NAVIC system. Along with the satellites, the NAVIC system contains 3 segments: the space segment, control segment, and the user segment. Space segment comprises of these 7 satellites. The ground segment is a very backbone of the very system, which is responsible for 24/7 operations and maintaining the accuracy, which is guaranteed by the NAVIC system. And the third are the user segments, which are the IRNSS users. This is the coverage area of NAVIC. We have 7 satellites, and our services are there in the L5 band and the S band. And I'm happy to share that very soon with the next launch, we'll be launching the services in the L1 band as well. The measured position accuracies are less than 5 meters and time accuracies are less than 20 nanoseconds. So we at ISRO are creating a stack of technologies for or a complete ecosystem for NAVIC, which comprises of the satellite itself. We are the providers of the satellite signals, as well as the applications. So these are the broad categories. I've classified them into three types: the professional applications, which are used in surveying, precision agriculture, timing, fleet management. Then the mass market application, which everybody uses, like in mobile phones, smartphones, drones, for personal navigation, and etc. Then the safety of life applications, like for search and rescue, disaster management, traffic surveillance, aviation, rail, and maritime. So these are the broad categories of applications, and I'll be touching upon few of the applications developed by ISRO. So these are the two kind of receivers. The first one is the FPGA based receiver for NAVIC, and the second one, you are seeing the chip in the middle. That is the first NAVIC chip of India, developed by ISRO at our foundry SCL Chandigarh. So this is the first baseband chip of NAVIC in India, and there is a receiver made using this chip. Along with the baseband chip, there is an also RF chip. So the receiver comprises of basically two chips now, the baseband as well as the RF. And using this chip, any developer can make their own NAVIC-based products. Industry is also not far behind. We have various chipsets available by so many companies now, catering to a host of applications like IoT. Then you have vehicle tracking, you have drone-based application. Then even now chips are available which can cater to the which are very less in power consumption and can be fitted in wearables, for example. The first application that I'll be talking about is the NAVIC messaging receiver. Along with everybody knows that GNSS, we can get position, velocity, and time, but we can also transmit messages with NAVIC. So these messages can be a lifesaver. We have fishermen going out in the sea, and they are not communicated to anybody, like they don't have any network. So they can pair their mobile phones and they can get a host of useful information, like whether they are crossing the international border inadvertently, or where can they find a good catch of fish, or the potential fishing zone advisories. Then they can get weather alerts like rough sea, cyclone, tsunami, etc. So these products are developed and they are under trials. Then we have vehicle tracking system. The experience has led to a regulation now by Government of India, which is called AIS 140, which has mandated the use of NAVIC in all public vehicles, be it bus, cabs. You must have a NAVIC-based tracking, otherwise you won't get an RTO permission for it. So here you can basically have the live visualization of a vehicle at a control segment. So now, within collaboration with ARAI and ICAT, more than 200 products are available for fitment in public transport vehicles. This is the NAVIC timing receiver, along with the position, velocity, and time. Along with the position and velocity, we also get time. So this time is used for basically financial network synchronization, banking networks, and mobile station synchronization, and even power grid synchronization. So on a pilot project basis, we have installed in 5 grids: north, south, east, west, and northeast, and we have synchronized their substations to NAVIC time. So we have got very good timing accuracies, and there won't be that day won't be far behind when we'll be self-reliant in covering all the grids across country with NAVIC system time. This is the NAVIC system time displayed on our website. It is live. You all can go and view this link, and you have a NAVIC time displays as well, which can be used for decimating NAVIC time. And for server applications, we have NAVIC-based NTP servers, which can decimate time. So the CRIS, Center for Railway Information System, MOSDAG, they all are synchronized to NAVIC system time. Even our launch operations are synchronized to NAVIC system time. This is a special receiver, NAVIC for geotagging applications. We have given 14 units to UIDAI Bangalore. This is for preventing or fraud checks at enrollment centers by the authorities. It basically geotags the position where the enrollment is made using NAVIC. It can be paired to the Aadhaar enrollment device. NAVIC for launch vehicle tracking, we have developed a NAVIC ruggedized NAVIC receiver, which can withstand the thermal shock and vibrations which the launch vehicle experiences. So the SAT receiver has been flown in 10 mission, and thereafter in every GSLV and PSLV launch, the NAVIC receiver is being flown, which accurately tracks the launch vehicle and finds the preliminary orbit determination of newly injected satellite. This is the NAVIC receiver for basically radio sounds. Here you are basically sending a weather balloon with some scientific instruments like temperature, pressure, humidity, profile. So you want to basically time tag the position and time of these measurements. And it requires a very light and very low power receiver. So you can flow these receivers and get the useful information. These are being used by using in the Pisharuti radio stations. For personal navigation, you can use NAVIC for hikers and climbers. Many industries have now come up with their products, marketing specially that they are made for India and made for NAVIC, and with Hindi support as well. Similarly, for rip current monitoring, we have done experiments at Visakhapatnam and Goa beaches to make the beach safer and to check what are the current situation of rip currents at those beaches and issue the advisories. These are the differential NAVIC receivers, or the RTK, real-time kinematic receivers. So not only at meter level, but you can also get centimeter level positioning accuracy with the differential concepts. So similar to differential GPS, now we have differential NAVIC, where you can have a pair of two receivers, and all the common errors of the two, which are seen by the two receivers, like satellite and atmosphere, etc., they get cancelled out, and you get very good accuracy. This can be specially used in the field of surveying and high precision applications. Now, the NAVIC is also available in smartphones. I'm happy to state that all the three major leading chipset manufacturers have offered products which are compatible to NAVIC. And using these chipsets, more than 30 mobile phone sets are now available in the market, which are supporting NAVIC. Very soon, a day will come when all the smartphones in India will be having NAVIC in their smartphones. Why this is important? Because a very important category of location-based services in smartphones are being regularly used by people. You might have used navigation while going from point A to B, finding a flight, or ordering food, or ordering a cab. So all these services, at their backbone is the positioning engine, which provides you the position and time. So this can usher a new revolution with the use of NAVIC. Being future ready is a good thing. So in the latest 5G specifications also, NAVIC is included, and TSDSI is in the process to adopt these specifications. So in the 5G also, you will be seeing NAVIC in future. These are the NAVIC-based apps for mobile, for messaging, as well as positioning applications. SAC has also developed many NAVIC antennas, which are very essential for the receiver to work. And industry has also developed many NAVIC antennas for dual band as well as triple band also. To test a receiver, you also need a simulator. So we have also developed a NAVIC-based simulator by ISRO. So these documentation, the ICD, Signal in Space ICD, is available on the ISRO website. The quarterly performance report as well as the messaging ICD is also available. So any chip manufacturer, industry, or startup can visit these websites and make their own NAVIC receiver chipset. NAVIC is also included in important industry standards for transportation, UAV, then 3GPP, 5G, differential GNSS like RTCM standard for L5 band, and NMEA RINEX, and also certified by IMO for navigation in open waters. Now it is also in the process of getting included in various other standards like RTCM S-band as well. Thank you very much. I hope I could honor the time and cover all the important information which I wanted to convey. Thank you very much.
Vibha, can I start?
Yes, sir. I'll just share the screen. Is it visible?
That's fine.
Yes. Good afternoon, everyone. I am Vibha Jain, scientist working for Satellite Communication Technology Division of SAC Ahmedabad, ISRO. Today, the topic of my talk is SATCOM for e-governance applications. Yes. SATCOM application services primarily comes in three flavors. First is the fixed satellite services, that is FSS, which is primarily targeted towards two-way point-to-point communications, where the end gadget are fixed and big in size as well as weight. It is targeted towards efficient volume continuous traffic, and the example for this is VSAT communication. The second flavor is broadcast satellite service, which is one to many users. For example, the broadcast services of DTH, wherein the size of gadget can be fixed, can be moderate, or it is indefined. The third is the mobile satellite service, MSS, which is basically point-to-point or point-to-multipoint communication. The basic usage of this MSS is globally used for voice as well as small data communication for maritime as well as disaster management service. Few of the terminal which we have proven for the MSS are reporting terminal, satellite mobile radio, two-way reporting terminal, or for video communication, we have portable multimedia terminal. All these are different flavors which supports one-way traffic or two-way traffic based on the demands. These are some of the existing popular SATCOM applications which we have proven and are in field right now. The left corner, you can see the satellite phone. There are two photos which I have provided for the satellite phone. First is the first generation, and the second is the latest one, which uses a normal Android phone connected with an RF front end to allow it to communicate through satellite. The second is the VSAT-based DMS network, which is basically used in case of any disaster when there is all the terrestrial link failure. Next is a distress alert transmitter to provide safety to the fishermen. A very famous application for the SATCOM network is a real-time train tracking information system, which is used by Indian Railways. Currently, most of the trains which we see are being tracked using this system. The next is two-way MSS terminal for coastal monitoring, wherein we track smaller boats going deep sea for fishing when they travel to the sea for even more than 15 days. In case of any emergency, if we want to alarm them, the system can be used. It is vice versa. We can alarm them, they can also alarm us. For weather stations, we have two applications. One is the automatic weather stations, where the data from a place is collected using this terminal and is communicated to a central location. And a tsunami early warning system to provide tsunami data through satellite. The first one which I have highlighted is the real-time train tracking information. This is a hybrid network which uses SATCOM along with the GPRS connectivity to track the trains. The usage of a hybrid network allows us to get an efficiency of even more than 99%. The main features of this network are SATCOM-based real-time train tracking, the visual display and navigational aid to the loco pilot, and it allows the dissemination of warning alerts to the loco pilot as well as the central station. We can even add the possibility of giving the passenger the information about the upcoming station, location, time, or the time exactly when it will be reaching the next station and other things. This slide I have put to show the image of the outdoor as well as the indoor unit. The left side shows two units. One is the outdoor unit, which is mounted on the engine, which communicates through the satellite. And the lower one is an indoor Indian Rail navigator, which is giving the aid to the loco pilot. It is communicating through satellite through a hub which is installed at Delhi. It is a 6.3 meter hub, which has the concurrent hub baseband, which gives this data to the CRIS data center. Currently, more than 2,500 locomotives are installed with this system and are being tracked across India. This is some of the snapshots which were taken while the proof of concept and the trial phase, where the terminals were installed on the engine. And the lower are the rail navigators, which is given to the loco pilot. These are some of the snapshots of the rail navigator view, which this is the first is the login page. Second is the track information. When you enter a train number, when the loco pilot enters a train number, he'll be able to see which track he has to follow, whether he's following the same thing. and he can send a message using the same logo, that navigator screen. This is some of the results we achieved during the pilot project. When we can see that the performance of the system in hybrid mode is even more than 99%. The second application which I'm projecting here is the National MSS Network for Coastal Monitoring. This is a network which was designed for tracking of sub-20 meter boats. The terminal, the second phase terminal, which you can see at the lower side, are very compact and very good to view. The salient feature of this network is it allows NAVIC-enabled position reporting periodically. It allows two-way small message communication. It allows the emergency message broadcast from the user. Currently, Tamil Nadu already have initiated the installation of 5,000 terminal on all the smaller boats developed traveling in Tamil Nadu. These are some of the snapshots of the terminal first phase proof of concept when it was installed on the boats. The lower side shows the GIS view of the NMS, wherein we can see the blue spots highlight the terminals mounted on the boat. So basically it is the boat, the location of boat at a particular time. We can also view the tracking of those boats in offline or the online mode. The third application was a real-time aircraft tracking system. Basically, Air Force came with a requirement that they wanted to track the aircraft while it is flying. It was not feasible. The main problem they were facing was when some cargo plane flew in around the ocean or in the hilly terrains, sometimes it went missing. They were not able to identify the exact location for search and rescue. So they came to us with a requirement that if in case we can give them some solution wherein they should be able to get the last location through which they'll have a defined search and rescue area. So we gave them a two-way MSS terminal through which they performed a lot of sorties around Kashmir, around Srinagar, Leh Ladakh, and Northeast. The performance we found during all those sorties were above 90%. So they have went ahead, they went to an Indian industry with the same requirement, and now they are getting 3 proto units for the trials. This is distress alert transmitter. Basically, as Nishkant sir also said, this is a distress alert transmitter which is used for the fishermen for their safety. Here we have added a return channel using NAVIC. So all the alarms, all the alerts from the central stations are given using NAVIC, while the fishermen in any distress can use the terminal using a simple alert buttons, that is medical, man overboard, fire, boat sink. He can alert some agency, that is, and MRCC can send rescue to him. Personal tracker application, basically for any kind of activity like hiking, hunting, nature study, or we can assume some army official going for a recce or something. If he carries this kind of a terminal wherein his position is known to the center, that where exactly he has traveled, in any case of when he needs to be searched, his position when known to the central station, it will be more convenient for his rescue. So we have developed this very compact terminal which can be mounted on his shoulder and his location is known. And that's all from my side. All the applications which we have demonstrated, we have developed to the user I have shown. So they are being developed and they are being used for the societal applications. Yeah, thank you.
Thank you, Vibha, for showing nice applications of SATCOM.
Thank you.
Now I request Pankaj to give demonstration on Vedas.
Yes, sir. I hope my screen is visible.
Full screen mode?
Yes, sir. Yeah. So good afternoon, everybody. Today I'll be talking about Vedas, which is a platform for visualization and analysis of geospatial data. So before we begin, before I talk about what Vedas is, I would like to first talk about why Vedas was built. So today we do not have any dearth of remote sensing data. We have large constellations like Planet Labs. We have Indian remote sensing programs, foreign remote sensing programs, which are collecting huge amounts and huge variety of data. and it is being collected at huge velocities. You have terabytes of data which is being collected daily. So the problem is really not the dearth of data, but if somebody wants to analyze this data, they require huge amount of infrastructure. They need huge network capabilities, huge processing power to actually make sense of data. So the limitations of this infrastructure, which are not really democratically or not publicly available or accessible to everyone. So the idea behind Vedas was to build a centralized platform which can be accessed by anyone, and it can help them perform interactive analysis based on their requirement and their parameters, and help them make sense of terabytes and gigabytes of data that is available to them. So what we do provide is we provide geospatial data visualization, archival, and analysis capabilities for remote sensing data that is collected using Indian as well as foreign satellites. So just to give you a glimpse of what is available is Vedas is you have interactive 2D and 3D visualization capabilities. And this is all developed using in-house software and taking help of open source packages. So we have past 22 years of vegetation monitoring data, which is available to you on the click at varying resolutions from 500 meter to 5 meters. We have big data analysis capabilities wherein all the analysis that you perform is carried out on multi-core processors, automatically parallelized. So you get very fast results in an interactive manner. We also have WMS services and APIs in case you want to use these visualization services and our data services in your own applications. And we are now currently building a scripting environment which is similar to Google Earth Engine, wherein you will be able to write your own code which will run on our servers to perform your analysis. So our goal is providing platform for research and training to academia by providing data, domain knowledge, and infrastructure. So I'll first begin with my presentation with some of the popular applications that we build. So one of the applications is the Global Solar Calculator. So the first thing it does is it at any location, at any point on Earth, it collates all data that is important for determining the availability or determining the solar potential at a particular location. So you have this insolation data, which in Indian landmass is calculated using InSat satellite, and using global satellite systems, we are calculating the insolation that is available at any location on Earth. And by fusing this data with the DEM available with us, and with the past historical seasonal data of solar radiation temperature, you can determine how much power you will be able to generate at a particular location. And all of this is available to you at a click. There is also advisory information like how much should be the optimal tilt angle to produce the maximum amount of energy, and whether there will be any obstructions which will be there due to the terrain. And the second thing, the second important thing that it does is it allows you to identify most suitable locations for solar power plants based on multiple criteria. So you can decide whether how much distance you want from the power line, how much distance you want from the road, what should be the slope of the land so that it is not too difficult to build solar power plants, what should be the minimum energy that should be incident, and what kind of land should it be, because you don't really want to consume too much of farmland to maybe build solar power plants and so on. So all this analysis, you can provide your specific parameters on the fly, and it will immediately calculate the most suitable locations to you, and it will provide to you on an interactive visualization. Another important application that we built was in collaboration with the Niti Aayog, wherein basically the problem was that whenever an investor decides to build energy infrastructure, he needs to collect information from 5 different ministries, and there can be bottlenecks there. So this portal aggregates data from all ministries. In fact, if you talk about the coal ministry, the data is coming onto this platform on a daily basis with regard to coal production and coal dispatch. And all this information at a single place is available for making investment decisions, is available for making decisions related to how much coal to import and how much fuel to manage and so on. So this provides an integrated dashboard with all information pertaining to energy generation and usage available to the users in a single portal. As I said, we have 3D visualization capabilities wherein important studies related to environment, studies related to cryosphere. So you have multiple data sets that you can visualize in 3D. For example, this image shows you the glacier morphology that is visualized on 3D, and the underlying DEM that we are using, that is also from Indian satellites, that is CartoDem. And you can see that you can play around and you can visualize all data that is available in 3D. This one application is related to hydrology. So what we are doing is basically using an altimeter at various points that are in the country. You will be getting observations regarding the water height. So this is also an important application in terms of hydrology. Coming to the analysis capabilities, and specifically analysis capabilities that we have built for vegetation monitoring across the country, you have all various resolution data available for monitoring the vegetation health of any location in the country. So if you click at any location, you'll be getting past historical data ranging up to 20 years. And if you come to, you can explore data from 500-meter resolution. And if you want to do analysis at a particular field level, you can go up to 5-meter resolution data, wherein for us, even for each field in the entire country, you will be able to get its historical vegetation profile, and you will be able to tell when a particular crop was grown, when was it harvested, and so on. So this has very important applications in terms of crop insurance and crop insurance settlement, and as well as premium pricing. You can also do online classification, wherein using the temporal profile or the phenology of the crop, you can determine in which area what particular crop was grown in a particular year. As I said, that we also have capabilities for ultra fast long-term analysis. I think this is one of the fastest platform for doing long-term analysis of vegetation health in the country. I mean, if you just select a particular date and you select a time range, it would automatically give you what was the minimum, maximum, and average image of the whole country at a single click, and what was the variability at that particular date. And this variability is what is important for deciding premiums for insurance. So just to give you a glimpse of how what kind of analysis is possible. So this image shows you the trend analysis that is performed using past 20 years data, so that you can get to know what is the impact of government funded programs. For example, this location here shows the impact on the growth of vegetation intensity that has happened due to building of the Narmada Canal. So you can select a particular date, and for that particular date in the past 20 years, what has been the trend in growth of vegetation in a particular region, you'll be able to find out. And all of these millions of regression equations are being fitted within a matter of seconds, and customized analysis is available to you. You can also do interesting queries based on your application area. For example, if you would like to find out which locations in India in the past 15 days have been affected by heat waves, so you can give your temperature range, select a date, and immediately as soon as you select your desired temperature range, it will identify what are the locations which are falling in your temperature range. And for example, if you give temperature from 40 to 50 or maybe 40 to 60, you can easily identify which areas are affected by heat waves. And similarly, you can use this tool to also for identifying, apply this tool for other data sets. For example, let's say NDVI. So you can easily say, I would like to see where NDVI is from 0.4 to 1.0 between this and this state, and it will automatically identify the locations for you. So going one step further, we also built a geospatial calculator, which if there is some analysis that we have not thought about, but you would like to do for your own research, for your own application, you have a GUI builder wherein you can create your own formula. And as soon as you click your button, you will be getting the output of that formula visible to you in the form of an interactive map. So we coming to AI applications. So we have, as I said, that we have past 20 years of data, and we have trained an AI neural network to automatically predict what is going to be the future vegetation health based on past data for a particular location, which really is going to help you identify and take proactive actions. For example, this future AI and VI values we are providing to agro-meteorological field units for providing advisory. All this data is also collated in the form of a dashboard, where you get your data in the form of charts, in the form of tables, in the form of GI. What is this kind of system is very useful when you want to declare drought in certain areas. So this can greatly help in that decision making. Another AI application for urban studies we have is that using list4 data, high resolution data, we are able to map where have the human settlements been built. So you have human settlements or human built up structures identified from satellite imagery directly using AI without using any human intervention. And we have already completed mapping of all 200 smart cities in 2 different time frames. So you can monitor where and how the cities are growing. And this can be extremely important for studying environmental impacts as well as for urban planning. Going one step further, using very high resolution imagery, using AI, we have automatically mapped building footprints, which can be important if you want to build digital twins or 3D city models. So what you can do is you can basically take these building footprints and take stereo pairs from Cartoset data and build a 3D height model. And then when you overlay this on building footprints, you get a 3D model of an entire city. And all of this can be built in a very inexpensive manner, which means it can be repeated often. And another application of this is once you have the building height information available, you can determine due to building heights and due to adjacent buildings, how much solar energy will be blocked and how much will be available to me during the entire day. So this can help you identify ideal locations or ideal buildings which are most suitable for putting rooftop solar plants. Recently, this AI model we have built that if you look at a satellite imagery, it is difficult to distinguish between cloud and snow. And especially if that cloud has snow crystals on top, their signature is also very similar. So it is very difficult to determine using index values whether there is snow at a particular location or not. So we trained an AI model to discriminate between the two. And when you take multiple satellite observations, these are automatically ingested by our system, and you get frequently updated and recently available snow cover maps in a fully automated manner, which are publicly available to everyone. Now, this becomes very important in case you want to monitor a road network and see which of the roads are being currently blocked by snow and what kind of efforts will be required to maybe clean it up and maybe make them available again. So in addition to optical data, we also have SAR data visualization and analysis, which is important for mapping floodwaters, which is important for mapping the damage due to floods, and important for mapping the water availability in the reservoirs and rivers. So these all are available to you, and you can do your own analysis, and you can monitor what is the trend of surface area of a particular reservoir. You can monitor which areas have been flooded recently in recent floods and so on. And as I said, we are also now building a scripting environment in which you can do your own custom analysis directly by writing your own code. So this is for power users wherein you want to do something advanced, and this will entirely be running on our servers close to our data. So all you need is a simple browser, a very basic browsing application, and you'll be able to do all this analysis online. Looking at the capabilities of our platform, we were also given an important work by the International Disaster Charter, wherein an analysis platform has been built for analyzing data that is contributed by international agencies at the time of the disaster. Thank you very much. This was all from my side. I thank my team for giving us the opportunity and Shashikant sir for moderating.
Thank you, Pankaj, for nice presentation. Now I request Utkarsh for presentation on MOSDAQ. Pankaj, you can remove presentation.
Yes. Is it visible?
That's fine. Carry on.
Yeah. So myself, Utkarsh, very good afternoon to all of you. I will be presenting the information and data services MOSDEC is providing. So MOSDEC stands for Meteorological and Oceanographic Satellite Data Archival Center, and it is an Indian storehouse for space-based weather and ocean data. And MOSDEC has a responsibility for archiving and disseminating the Earth observation satellite, specifically that are working in the Mat ocean areas, along with the different location-based services that I will try to give an overview of. So MOSDEC is basically well known amongst the satellite data centers at national and the international level, and engaged in multiple collaboration with the different agencies and international space agencies as well, because it is working as a storehouse for Indian space-based mat and ocean data. It is responsible for disseminating these data in a near real time over high-speed networks. It provides a plethora of information services that can be directly plugged into a decision support system of multiple agencies or the private agencies. It also provides the information in the weather-based alerts and in the different modes. And time to time, we releases the different tools and utilities for the scientific data analysis. So as you can see over in this satellite, in this slide, we are supporting the data from the since the Kalpana 1 launch that was launched in 2002, and till the SCATSAT 1 that was launched in 2016, and along with the new launches that are going to come up related to INSAT 3DR, OceanSat, and others in the Mat Ocean field. So this is the homepage that can be accessed through mosdac.gov.in, and to facilitate all those collaboration and providing information and alert-based services, MOSDEC has taken a lead in deploying and implementing next generation digital tools and techniques that will now I will try to give you the glimpse of. So the mandate of MOSDEC is related to the data dissemination and providing the information services, web-based application tools and techniques that will make the life of researchers or the end users or the agencies easy. We have at MOSDEC registered users from international as well as the national levels. We are supporting the past missions, current missions. You can see the list over here, and the near future missions like INSAT PDS, GISAT, SCATSAT, and OceanSat 3. We are also hosting a lot of in situ data that are coming from the in situ the sensor networks like Doppler weather radars, automatic weather stations, agromet stations, and the different Calwell sites that are used for the calibration and validation activities of the satellite data. And we are also involved in multiple national level projects, like you can see some of the names over here. So this increases the mandate of MOSDEC from the satellite data processing to the design and development of different sort of softwares to provide these data to the end users, providing data and information services on the basis of these data, and provide the common analytical platforms as well as the data quality, controlling the data quality of satellites. So this is how we are managing our things. These are the fully automated process running at the MOSDEC, sees the data reception from the satellite data through the ground segments, and the data processing, generation of the data products, and then the international standards for the metadata generation, so that the metadata can be shared amongst the different space agencies, and then finally the dissemination. So these are to give you a glimpse of the users that we are serving. In terms of international, different space agencies are involved. And apart from these national users, different educational institutes, government agencies, and the private agencies are included. So I will first tell you about the information services MOSDEC is providing that are related to the forecast, nowcast services, MAT and ocean-based services, alerts and forewarnings, satellite image galleries, advanced analytics, and open data. For forecast and forecast, we are providing the city weather forecast based on the WRF models, cold wave, heat wave forecast, heavy rain forecast, lightning, monsoon, sea state, solar energy, and wind energy in terms of renewable energy. These most of these forecasts comes from the different mathematical and the physical models that runs at the high computational facilities at the MOSDEC. And we are also providing the nowcast-based alerts. Nowcast and the forecast are different in terms of validity of these warnings. Nowcast are short, has a very short validity and immediately valid for next 6 hours, whereas the forecast are valid for the next 3 days. That is 72 hours. So we are providing the cloudburst and the heavy rain nowcast alerts. Met and ocean services, we have customized application for the energy named as UJA, rain-based dissemination of information, that is Varsha, and the air quality related information through the Vayu portal and the soil moistures. We are also providing the cyclone track and intensity predictions starting from the cyclogenesis or the inception of cyclone through the Scorpio portal. Oil spills, oceans, subsurface fields, safe beaches that tells you the state of beaches in terms of rip currents or the probability of rip current at a particular beach. Ocean Eye, that is being used by the naval Indian Navy or the other merchant navy groups or the private agencies for the for determination of tracks of their ships and the eddy currents. Alerts and forewarning, we have our own portal that disseminates the different extreme weather alerts through Indian State Portal. And we are also disseminating these alerts and forewarnings for the Southeast Asian countries, and they have their own different portal. We are also disseminating near real-time image galleries and providing advanced analytics through our own live portal that is known as Let's Interactively Visualize Earth, where you can bring the data from all different sources that are hosted at MOSDEC and can view in a single window or a single screen and can do the analysis of the point probing and different sort of analysis over that. We are also, we have hosted the science products as open data that are available for anonymous users. And these are the list of all the science products that are available as open data. So if you can see over here, this is one of the portal that we are showing over here, that is solar and wind energy that is available through the WRF model, and it is available at an interval of 15 minutes. The wind energy we are showing in this, and at every 15 minutes interval for the next 3-day forecast is available across India and surrounding region, and you can easily enter any latitude and longitude, and you will come to know the WRF based forecast for solar and wind energy. And another image over here showing the contrail forecast services that we are providing. This is the contrail forecast that you are seeing over here, and that is used by the aviation industry, and the cloudburst forecast along with the land use land cover to immediately know the impact analysis of the cloudburst if alert turns into the reality. This is another portal that is weather forecast related to the weather based on the WRF model. And this is also available along the across India and the surrounding regions, and you can enter or select a particular city or latitude, longitude, and you can come to know all about the cloudiness, wind speed, temperature, surface pressure, rains, humidity forecast for the next 3 days. So these portals are all available at the MOSDEC. Another important activity that we are doing is the cyclone track and intensity prediction, and that is available through the Scorpio portal that is available at MOSDEC. You can see over here, we are predicting the track, and we keep on updating this track as and when the things or the forecast turns into reality. We are showing over here the blue thing is the real track and the red one is the predicted track. So this is very handy in terms of any cyclone-based disaster whenever a cyclone hits in the ocean surrounding the country. Another important Met Ocean service that we are providing is a rip current forecast. This system is available for the all India beaches, and it provides weather probability of the rip currents. Rip currents are basically the strong currents that flows from the shore into the sea or the ocean, and it is responsible for the deaths of so many of the tourists. So the many agencies that are managing the beaches are interested in this type of forecast, and we are providing operationally to the many of the such agencies that are taking care of the beaches for the tourists to raise an alarms in a timely manner. And apart from this, we have Ocean Eye that takes care of the suggesting the best or the possible route of ships or the merchant ships that are taking goodies through the sea routes. And ocean subsurface field analysis that takes care of the different parameters that are beneath the surface of the ocean, the eddy current visualization. These all the applications have the different application users and very crucial for these for certain applications. The another new thing is a state portal. Over here, we are providing the alerts related to the heavy rain, the cloudburst, and this is the most recent from the 8th of July. I have taken a snapshot of. You can see the heavy rain cloudburst alerts are present, and it will quickly let the users or the authorities to plan accordingly. And these are the nowcast alerts that are valid for the next 6 hours. And this similar portal is available for the Southeast Asian countries as well. So in terms of the near real-time satellite imagery, if anyone is interested in viewing or integrating the satellite imageries that are coming through the satellites, we have a very nice satellite image gallery system. Over there, you can easily select the kind of satellite you are interested on, the products, or if you are interested in L1, L2, or the real geophysical parameter, you can quickly select over there and can see the slideshow, and with the ease of selection of frames as well from the past dates. So you can control the past dates as well. And this is the light that lets interactively visualize Earth platform. Over there, you can see we are supporting the 2D and the 3D based analysis. And you can, this is a single platform that combines the satellite products of all the satellites, in situ data, as well as climatology or other sort of all the sources, data from all the sources that are received at the MOSDEC at a single platform, so that they can be overlaid, they can be viewed together, and they can be shared, snapshot, or you can easily share. It can overlay the forecast of different agencies as well over this using this particular platform. So this is very important for the analysis part if one is interested in. So next thing is a 3D visualization that is available. You can see over here, there's a climatology we are showing, and as well as the SketchSat winds. So this type of 3D visualization is available using the live platform. So these sort of open data is available in terms of science products that includes the wave power, sea ice occurrence probability, inland water height for the inland reservoirs, ocean surface currents, and the river discharge. So apart from this, now I will move on to the data services that we are providing. And this includes the satellite data from all the satellite that has been launched by the ISRO. And we are also have a planned missions in SAT 3DS, GISAT, and SketchSat 2, OceanSat 3 as well. And we have also established our own in-situ data network. And these are the different sensors, and these data are available through the MOSDEC. So this is just a glimpse of AWS automatic weather station network that is established, and the data is received at the MOSDEC and the DWR that are operational at Trivandrum, Sriharikota, and Cherrapunji. So in terms of data dissemination, we have implemented different techniques and the next generation tools to provide the data to the users that are available through APIs, through mobile applications, through RSS feeds, email-based data dissemination, WMS, web-based web map services, thread servers, and the data casting. And the capabilities include each data product has its own unique DOIs, and the metadata harvesting, you can directly integrate our metadata services with your own portal. And these are many international integrated platforms are using our data for the metadata harvesting. And we are providing the subscription-based data access as well. So this omits the need of coming to the Mosaic portal for the data. You can directly get the data on your system. And we are providing all this through the API mechanism. So this is just a snapshot to give you an overview of how the data can be ordered using the user order processing software developed at Mosaic. So these are the different sort of services that we are providing, and API-based data access is available for the extreme weather event alerts, solar and the wind forecast, weather forecast, data services in terms of AWS data, open search to integrate the Mosaic catalog with your catalog, and the RIP current forecast that is available in an interval of 6 hourly for the next 6 days. We are also developing the different sort of mobile application, and one such application is the using the Amazon Alexa skill set. We have developed this skill set to use the mobile used on mobile the Mosaic microservices using your voice commands. You can see that in the snapshot, you can just give the voice command and it will read out the different forecast available to you at your location. And even you can tell the location in terms of city name or the location or the popular landmark, and it will keep on telling you the weather forecast for that particular location. And apart from this, other mobile application that we have developed are the weather applications that are available for the common public. The Safe Beach that is being provided to the tourist department in the common public for to assess before going to a particular beach what is the RIP risk probability over that beach. And we have also provided a mobile application for the Goa beach tourism to collect the beach events that are related to the RIP current. And these all are mobile applications are developed using the low energy location sensing and prioritization of the next generation techniques like caches and taking advantage of the high computational powers of the now available mobile platforms. We have Mosaic is also involved in providing the customized solutions to the different departments. And one such project or the ISRO level project is MMBRPS. Mosaic was played an active role in that. In this, we have provided an all-inclusive user demand-based and customized system to cater to the operational requirement of the IMD. And this entire chain for the INSET 3D3DR is being established and is being operationally used by the IMD through the project that is known as the Multi-Mission Metadata Ocean Data Reception and Processing System. We are also working on in a close collaboration with the other stakeholders as well. For example, for the renewable energy, we are providing inputs to the National Institute of Wind Energy Power System Operation Corporation Limited, and they are operationally using our inputs. And for the disaster management, Gujarat State Disaster Management Authority, Karnataka State Natural Disaster Monitoring Center. Aviation industry, we are providing inputs to the Indian Air Force. For the naval operations, Indian Navy Shipping Corporation of India for the ship routes, etc. They are using our things. And for the agromet industry, Bihar State Agriculture Department, we have MOUs with all of them, and they are using our inputs operationally. So that was my last slide. And we are also working on right now to provide the weather data cube and ocean data cube so that we can provide the web analytical portals and the on-demand computing to our users or the agencies, so that there's no more need to download the data to their local storage or the local computers. And we are also working on the scalable online analytics, and we have performed certain POCs over that, and we will soon be releasing these things in the public domain. And for any more questions or something, you can always contact us as admin@mosaic.gov.in. Thank you. In the end, I will just try to, I have tried to give an overview and hope that was able to give a good glimpse of entire gamut of Mosaic services it offered for the societal application. Thank you for the mighty for giving the opportunity, and thank you, Shashikant sir. Thank you.
Thank you, Utkarsh, for a nice presentation on Mosaic. Now I request Arul Raj from NRSC Hyderabad to give a presentation on Bhuvan and Bouni, the portals. So over to Arul.
Good afternoon, all. Fine. First, thank you very much for this opportunity. And I'll be talking on this Bhuvan and Bouni solution with reference to the G governance. Yes, we will start with the Bhuvan, and the second part of the presentation will be on the Bouni part. The first one is the Bhuvan. Bhuvan means earth in Sanskrit, and it is providing a host of services. So different kind of visualization services are offered. In this one, in the 2009, we have started as a simple visualization tool. In 2010, we have complied with all the Open Geospatial Consortium standards and the services. And we
Arul, your presentation is not seen. Arul, please share your presentation first.
Hello, you are able to see my presentation? Hello.
No. Now it is coming. Just wait.
Yeah.
Share the full screen. Just 1 minute.
It's in full screen only.
Yeah. It's coming. Still not. Now it is okay. Fine. Carry on.
Okay, fine. All right. So the first part of the presentation will be on Bhuvan, and the second part of the presentation will be on the Bouni. So Bhuvan meaning earth in Sanskrit. It is realized in 2009 as a simple visualization. Today, you can see that Bhuvan with more the analytical capability, mainly for G governance relativity. In this last 2 years of journey, we have started as a tool, then we have gone into some kind of data archival system where the Open Data Archive is providing host of data sets for free download. Then several services which is compliant with the Open Geospatial Consortium standard, and that is the way we are sharing the data and the thematic and the earth and the climate science related information. All those things are shared as OGC services. And now we are focusing more on the governance application. The journey started is visualization, then we have gone to the centric application, then the user centric application part. Now, the whole Bhuvan in a single slide. I have that the one is having almost like 60 terabyte of data for visualization, for analysis, or serious analysis or time and you want to do it, you have the 60 terabyte of data ranging from the 56 meter resolution to the 1 meter. The data sets are available in Bhuvan. You can see that applications are run Bhuvan for various ministries and state or central ministry or certain applications, citizen centric.
Yeah. Arul, let me share the presentation. That will be better.
Hello.
I will share the presentation. You just speak. That will be better.
Okay, fine.
Now it is
Go
okay.
ahead. Yes, sir, it's fine. Okay, we have mobile application, almost like 70 application, which is mainly for the inventory purpose, and certain applications are for the monitoring purpose. And also is having the component from the citizen to contribute to many data sets for the crowdsourcing point of view. Then we have like 100 plus thematic information which is available as a services, or some of the data sets are available for free download, which also include our climate and environmental related products. So that is the way the Bhuvan is having the wide variety of data, which is mainly going for this analytical point of view. Then I'll move to the next slide. Yeah. Now, if I go further, then you can see that the 2D, 2.5D, and the 3D visualization, how it will be looking like. This is the slide. The building footprint is taken and it is extruded from the ground. So that is the way the tiles are looking. And we also have the texture which is added to the building footprint, and you can see that how the 3D models are looking like. And the data clearing house, the NRC Open EO Data Archive, what I was mentioning, that it is having almost like 80 different products which can be downloadable. And you, whatever the screen you are seeing here, it is the 1 degree by 1 degree tile which one can download for the, this is the 56 meter the AVIVS data which can be downloaded. Almost like 40 different time frame the data sets are available. One can download and can go for a time series visualization. Then the thematic disaster, weather, and ocean related services are available as a open geospatial consortium compliant services. And the next component of the capability of the Bhuvan is it is having a lot of asset mapping and the monitoring component. The example what you are seeing in the screen is the housing application. The Pradhan Mantri Awas Yojana housing, the different stages are monitored and it is put up in Bhuvan. The physical progress is again linked to the financial progress of that a particular the project or particular scheme. Then we also have a planning and a development component in Bhuvan. And what we are doing is we are having a different kind of models. The model is like which is pre-built and it is available in Bhuvan, or else the users also can upload that layer and they can also apply the knowledge from the field and they can modify the model and again they can run it. So that is the way the different scenarios can be created and the decision can be made. The next component is the monitoring and evaluation. And here you can see that the two kind of evaluation we are trying to bring it. One is the field-based thing based on our time series mobile application, photos which is coming from the mobile, how the impact is there on the ground. The second thing is the continuous or the time series satellite data sets are put up and what is the impact on the ground. So that is the way the monitoring and evaluation is happening. And it is also giving certain kind of facility to go for a decision making thing. Like for example, in the given example, so once the biomass related informations are available from the different crops, and we once the area is selected and which will be the what kind of kilojoule or the power can be generated from that particular area, that will be automatically suggested to the user. So that is the way the models are built and it has been kept here. The next thing is the reporting and advisory. It is not only a one-way data what is landing to the Bhuvan server. It is also processed in the Bhuvan and also it is disseminated to the various expert group, and the information is again collated and again pushed back to the user in the simple SMS way. So that is the way the two-way communication is put up and in terms of the reporting and advisory point of view. And a lot of natural resources informations are available and it is put up in Bhuvan for the natural resources management. And now, as these previous speakers are mentioned, that we have a lot of location-based services which is running on Bhuvan. So this is the typical example, like the vehicle tracking application, which has been put up for the Election Commission for monitoring the route officer vehicle. So this is the one example what I want to show it. Now, if we see that when we are speaking about all the capabilities and the tools, what is available in Bhuvan, the base is the data sets. If you see that complete data inventory, what we are having in the Bhuvan, as I mentioned in the 60 terabyte of satellite data, you have the data from 360 meter to 1 meter, and you can seamlessly visualize all the data sets into that. Then you have the administrative boundary from the international boundary to the cadastral level, you are able to see it. Then when you are seeing the infrastructure layer from the golden quadrilateral or national highway to the footpath or the car track, you are able to see it in Bhuvan. then the point of interest data, whether it is a newly opened ATM or post office or a worship place, or it is a very important installations or points in the country, you will be able to see the point of interest data in Bhuvan. And the data download is having the major thing from our multispectral satellite data or the hyperspectral satellite data or the derived products, whether it is NDVI or vegetation action or the data sets which is related to the environment and the climate. Those data sets are available in Bhuvan for free download. But a lot of national imperative applications or projects are carried out by National Research Center and the ISRO. And all those thematic data sets are available in Bhuvan for easy to access as a simple web services we are enabling to the user, and they will be able to access it. By having all these data sets, our ultimate aim is to have a interoperability in place. So we don't want to user to recreate the data which is available. The data should be easily shareable and they will be able to make a decision on top of it. So that is the way we are having today almost like 10,000 plus different services which is running on Bhuvan from the high available services. So that is the way the data and the services are put up in Bhuvan. And who is using all these data sets and the capabilities are what we are having in Bhuvan. So today you can see that almost like 43 state and the central military departments are using Bhuvan. You name it, whether it is the Department of Agriculture or the Ministry of Shipping or the Ministry of Panchayat Raj or Ministry of Minority Affairs. Just 2 days before, we have launched the application for geotagging all the minority concentration area assets. And on top of it, what is the further value addition it can be provided, and the service is also enabled to the Ministry of Minority Affairs. That is the another example what we have put it. So like that, you take the Election Commission, we have supported the Election Commission of India, and the same way we have a MOU with the RBI for all these bank location and ATM location, and they are using in the environment for making various strategical analysis. So like that, you can name it any particular department, you have a very good application which is running on Bhuvan. So that is the way the data repository what we are having in Bhuvan and the analytical engine what we have put it on Bhuvan, that is being used by all these departments in the country. So this is the typical example. But when you go further, because today we are most of our discussion going on with the NAVIC also. Here you can see that we also have many location-based services. The very popular example is the vaccination center location, and it is also linked with the CoWIN API, so that any citizen they can locate that where the vaccine is available and how to navigate from their location to another location. That there is running on Bhuvan. In the same way, there is, suppose if anybody is landing to any new place and they want to locate the post office and they want to navigate from one location to another location, or what kind of services are offered by the post office, it is having an example in Bhuvan. And the same way, the health sector is a critical one, and the entire Andhra Pradesh CM scheme, we have put it on Bhuvan, and people are able to see whether that particular thing is covered under the scheme or not. If it is covered under the scheme, which is the nearby hospital, which is the nearby blood bank, or the medical facility which is available, they will be able to locate it. Anyway, the Election Commission I have already mentioned. Now, why I have highlighted this Aadhaar UIDA 2.0 is during the same Digital India Week, we have released this Aadhaar application. Today, any citizen, they will be able to locate which is their nearby Aadhaar center. Suppose if they are looking for only the address update, they can navigate to the nearest thing, or if they are looking for taking a new Aadhaar thing, they will be able to access all this information from Bhuvan. So that is the way certain locations applications are also running on Bhuvan. The very popular thing is the ease of doing business for Archaeological Survey of India. If anybody is going for a new house construction, then it will be uploaded into Bhuvan, and it will say that whether they are in the protected area or prohibited area or regulated boundary. Accordingly, the do's and don'ts, all these things will be created, and the image chip will be shared to the applicant. Then applicant has to submit the information to the authorities. So that is the way the end-to-end chain is also built, and that is the example what I have put it here as a small screenshot. Now you can see that only two examples I want to highlight it as part of my presentation. But as I told that almost like 195 application which is catering to the 40 plus ministries, departments they are using. But highlight is because of the time I am highlighting only two applications. One is the Mahatma Gandhi National Rural Employment Guarantee Act. We all know that about that scheme and how many days it is running. We started that application as a simple inventory so that one should know that what kind of asset is created in that place, whether the asset is available in that place or not. Then by seeing the success of that one, the ministry has come out and asked that we want to monitor that progress of the asset. So now here the asset is whether the farm pond is there or the check dam is there or any road is being constructed or any building is constructed or our new plantation is put up. These are all the different activities. You know it very well in the country under the rural scheme it is running. So then the second component is that before, during, after, like that, we have introduced the monitoring component. Then by seeing that success, the ministry has asked now that we want to use this Bhuvan for making a plan, because where to construct. So that plan creation, we have enabled a tool in Bhuvan. So what it will do is whatever is the available data like land use, land cover, soil, slope, stream order, all these informations are available. Using this one, the probable location is on the fly created to the user and it will be showing that one. From there, they can apply and they can local data or they can refine the data and they can again finalize the probable location where the scheme will be can go for. Then further, it will be taken to the Panchayat and it will be discussed. Again, it will be taken to the next level for the approval. Then it will go for a further geotagging. When it is happening, then we have also brought out another parallel application, the mobile application, so that the activity and the sub-activity, whatever is going on in the ground, it should also have the geofencing component so that the next time the user is going, they should exactly take the information from the same location and they should put it. So that is the way the plan preparation and plan monitoring is also now invoked on Bhuvan. So that is the way you can see that starting with a simple geotagging, then the monitoring, then the planning component is also put up in Bhuvan. Then the next thing is just I have explained that during this Digital India Week, we have released this Bhuvan Aadhaar Seva Kendra application where one can geo-visualize the entire Aadhaar Seva center. You can see that the entire country, how many centers are there. Each and every state is represented with one circle. How many centers one can understand in this one. From this, like suppose if I am using my mobile application, you can locate that where is your nearby Aadhaar center. We pick that one, whether I want to do only the child-related entry, I want to do it, or I want to change my demography detail. So it is having 4 different groups. It is also highlighted with the different color. And then once you pick up, then what is your current location? What is the location of the Aadhaar center? Then you will be able to navigate from your location to another location. And it is also having the pin code search. You can enter your pin code. Under that pin code, how many Aadhaar centers are there, which is nearby, you will be able to get it. Or you want to go for a filter based on your category wise, you will be able to do it. So like that, whether it is a planning component or it is a citizen-centric application, where we want to bring more and more the schemes of the country and put it on Bhuvan, and it can be really helpful for the administrator for making a better decision or the citizen for utilizing that particular scheme, what is available. So that is the way the digital thing is enabled in Bhuvan, and Bhuvan is providing the platform for all these applications. So this is another thing. I will just skip this particular slide. Like during the COVID also, we have helped the government of Telangana, government of Tamil Nadu, government of Bihar, and we have also brought out a vaccination center location for the PMO. All the things has been put up. Here you can see that this is a typical example of how the farmers' cart tracks are monitored and where they are moving, because during the lockdown time, the vehicles are not allowed in the field. So that way, the vehicle tracking has been put up, and the same way, the citizen also able to contact the administrator that this area needs certain kind of facility. They are able to divert the vehicle to that particular location. So this is a typical example. And the second is the COVID Bihar, the containment strategy, what we have provided. Wherever the clusters are identified immediately, the 1 kilometer, 2 kilometer, 3 kilometer, 5 kilometer, 7 kilometer buffer zones are created. And based on that one, which are all the villages are covered in that zone, and what is the population, what is the age group, everything is on the fly. The report is created in the Excel and in the PDF, and it is available to the user so that they have gone for a field visit and the field survey. So that is the way the health emergency center, which is supported through Bhuvan, and this is the vaccination center location, and the COVID API, we all know that very popular, and how it is integrated into Bhuvan. This is the screenshot. And the same way, like last year for the COVID bed related information, information also we have put it. One can understand like whether it is for a severe case where it have to go, or mild case, what is the facility it is available, how many beds are available, whether it is an oxygen bed or a normal bed or ICU bed. One can understand and they can have all these details. So this also we have supported in the COVID pandemic time. This is another example. Now, when we are talking about the Bhuvan, we have talked about more data for visualization, more data for download, and most of the data sets, whatever we are having is for a governance thing. So that is the way our framework or our APIs are put up. On another side, we have a Bouni from NRSC, the National Remote Sensing Center, Hyderabad. What exactly this Bouni means? So Bouni is providing the access to all the users almost from the 44 different satellites in the last 30 years or 3 decades. The information, whatever the satellite data sets are archived, it is available in Bouni portal. So one can access, one can browse, one can understand, and then they can order the data for whether it is a free download or whether it is a paid thing, they can able to do it. Apart from that, when we are talking about our Indian remote sensing satellite data, we are also giving the regional hub for the Sentinel and the Landsat data, and that is also available in Bouni. So today, if you see that the Bouni, the main component is the Bouni browse and order, and apart from that, you have a Bouni Vista. Then you also have a Upahar. These are all the two other byproduct which is also available along with the Bouni. What exactly it is? Now, as I was mentioning that, you can see that the Bouni, the browse and search mechanism, whatever is available, you can see that the 44 different satellite product for the last 30 years, the data sets are available. One can search, view, and download if it is a free one, or if it is a paid one, they can order, and then based on that one, the FTP link will be provided and they will be able to download the data. Then the second thing is for the regional hub, the Landsat, Sentinel, and Novasat satellite data is also available. That can be also accessed, that it can be downloaded from the Bouni portal. The another thing is the Bouni Vista, and where one can able to understand that the temporal or the mosaic, the composite data, whatever we have created, and it has been visualized on the Bouni portal on the fly and in the near real time. The next thing is the live tracking, because this will be very much helpful for planning your particular activity, whether the particular area is covered by the satellite or not. If you want to go for any data ordering, then this will be the orbital viewer will be very much helpful for planning your activity. And if you see that what kind of data sets and what kind of the user base, all these things are available, it is also catered by the reports and statistical module. And now it is also coming out with the different kind of API, and it is also using that one. We can go for different on-demand EVO analysis on top of this Bouni portal. With this one, thank you very much. And more and more information can be accessed from bhuvan.nrsc.gov.in and bouni.nrsc.gov.in. Thank you all.
Thank you, Arul. And at last, I thank all my presenters for giving a very good presentation on all the 5 topics, ranging from satellite communication, satellite navigation, data dissemination, and analysis. Now the floor is open for question answer session and discussions. So we would like to take some questions available. So one question related to AI that Pankaj can answer, how the past data for AI models, where and how it is being sourced.
So there are 2 kinds of things that we need to do. We need to look at. So one of some of the kind of models are that we are trying to predict the data itself. So therein we need not prepare manually the data. For example, we have past 22 years of NDVI already. So considering n+1 data is unknown, it is quite easy to train. Whereas in case of semantic segmentation like snow cover, we actually have manual experts who are sitting and preparing training data for our AI models.
Okay. Then another question for Arul Raj. You have a lot of information, geotagged information for Manrega, with photographs and geotagged information. So what type of data analytics is planned so that it can help the government in a better way?
The current one is going on is like as soon as there are two components I will put it. One is for the administrator point of view for the moderation purpose. One is as soon as the data is landing into Bhuvan, we will also be searching that whether the citizen information board is there in that one or not. Then we have another model to identify that whether that is falling into particular class or not, to have a automated thing. So this is the inside activity. But for the administrator, for the planning purpose, as I was mentioning in the my slide on the Yuktadara Bhuvan planning portal, we have a component from the existing assets. So we call it as a convergence of all these activity, like whether any activity, whether it is coming from the IWMP or it is coming from my RKVY program or it is coming from the MG Narega program. All these assets are collated and it is made available on the single platform, so that whatever the new activities they are planning, they can always avoid for the duplicate of the activities which is going to be in the place. So that is the way the existing assets will be helping for the administrator to avoid any kind of duplicate. So that is the model is in place as part of the Bhuvan planner.
One more question for Arul. Are we planning Indian data also, which will be freely available to all Indians for their analysis?
See, today, if you see that whatever the NRC Open EO Data Archive, what I was mentioning, last almost 10 years, the data sets are available freely from NRC Open EO Data Archive. The somehow like almost 80 different products are there in that one. But if you are talking about purely the satellite data, the 56-meter AWIFS data is available for free download, and 23-meter LIS3 sensor data is available for free download. Almost like a 40 different time frame, the AWIFS data is available. Almost 27 times the LIS3 data is available for free download. Now, more and more the higher resolution satellite data also will be possible in near real time, and the things will be available in the short period of time. Thank you.
Thank you all. Thank you, organizers. I think we have crossed the time, 3 o'clock. So I don't know whether we'll be able to take more questions. If not, I will be happy to hand over the stage to Digital India team.
Ms. Vanshika, you may conclude the session.
Sure. So with this, we come to an end of today's session. I extend my sincere gratitude to our esteemed speakers for walking us through the varied programs directed to achieve the vision of ISRO, harness space technology for national development while pursuing space science research and planetary exploration. The session fetched us an invaluable insight into space technologies developed indigenously and how they are catering to various segments related to the life of a common man. Special thanks to our moderator, Mr. Shashikant Sharma, for graciously moderating the entire talk and ensuring smooth flow of the session. Last but not the least, I thank our participants for engaging so actively in today's session. You will find the recorded version of the session on our social media handles and channels. Thank you, one and all.
Thank you. Namaskar.